Let's say the travel agency tells us that this reality has changed. Each tour still offers multiple tourist attractions, as before. But now, each attraction can also be included in multiple tours, not just one as it was until now. In other words, the relationship between tours and attractions is no longer one to many, but many to many. How do we represent this in GeneXus? The solution is to use two transactions, one for each entity. In addition, we add one of them as a second level of the other. We do the latter taking into account how the data is going to be entered. If for each attraction, the tours that include it, or if for each tour, all its tourist attractions. In our case, the agency asks us that when the user is going to enter the data for a tour, they can already enter all the attractions included in it. So this model is the one we need. Let's do this in GeneXus. We open the attraction transaction, remove the tour ID and tour name, attributes, and save. We can see in the output that an error appears. This happens because when generating the pattern in this transaction, several rules were created automatically to implement everything necessary. And some of these rules use the tour ID attribute. We comment them out or directly delete them. And now when we save the changes, we can do it without any problems. Now we open the tour transaction to add a second level. We create the attraction ID attribute and notice that when typing a key attribute starting with attraction, the level name automatically changed to attraction. We also add attraction name and attraction photo. Let's see how this relationship is implemented, opening the diagram we had between the attraction and tour transactions. Now there is a double arrow at each end of the relationship, which indicates that the relationship is many to many, also called N-to-N. That is to say, that an attraction is visited by many tours, and that a tour includes the visit to many attractions. Let's now look at the tables that GeneXus creates from this. Design. We see that associated with the transaction attraction, it creates the attraction table, and associated with the tour transaction, a table called tour, and a table called tour attraction, corresponding to the sub-entity where the attractions that are part of a tour are represented. Let's create a new diagram to visualize the relationships between these tables. In addition to creating one table per transaction involved in the many-to-many relationship, GeneXus also creates a third table to establish the relationship. If we examine the structure of this third table, we'll see that it includes only the identifier attributes from the other two tables. Therefore, whenever GeneXus defines a many-to-many relationship, this relationship will be represented in the database by three tables, one for each participating entity, and a third one with the identifiers of both. The many-to-many relationship between attraction and tour was decomposed into two one-to-many relationships, using the tour attraction table to establish the relationship between the previous ones. This third table may also include its own attributes, representing data that belongs specifically to the relationship between both entities. Let's see this with an example. But first, we save the diagram and close it. We open the tour transaction and add the tour attraction date attribute to the second level. This attribute represents the date when the tour started, including that attraction. Let's save. If we now open the diagram again, we see the newly created attribute in the relationship table. This attribute gives additional information to the relationship that is established by the identifying attributes of the other two tables. We press F5 and accept the reorganization. We open the tour transaction. And now we see a grid to enter the attractions visited in the tour. To the tour Magnificent Paris, we assign the Louvre Museum and the Eiffel Tower as attractions. For the date, the tour began to include each attraction. We enter today's date. As mentioned earlier, we could also have configured a default rule to automatically assign the current date. Let's confirm. We go to the next tour and add the Great Wall of China as an attraction. We've seen how to model a many-to-many relationship between entities. We also concluded that when creating and relating transactions, we must consider not only their structure, but also the user experience when entering data in the transaction screen, which will guide us in choosing the most appropriate type of model. In our example, we chose to enter the attractions visited by each tour. However, we could have chosen to enter the tours that include each attraction, or used other models that are not covered here, but which would also result in the creation of 3 tables, one for each entity in the end-to-end relationship, and another that establishes the relationship between the two.